So on behalf of DIA, I thank all the principals and the management authorities who have joined from KPS and given this opportunity to us to share with all your children the basics of coding, robotics, and AI. So our founder, Mr. Uday Shankar, is eagerly awaiting to give you an overview on these interesting topics. So children, please hold your breath and keep your eyes and ears open for the next 45 minutes to 1 hour for an exciting journey which will take you to futuristic knowledge and learning. Enjoy. Over to you, Uday.
Thank you, ma'am. Hi, good evening, everyone. So today we're going to learn something very interesting. We're going to understand what it is and what the possibilities are with coding in terms of game design and AI. Let us go through in a stage-wise manner. A warm welcome to all of you from the Do It Yourself Academy. We are into internationally certified, industry-oriented courses on coding and robotics. So what is special about this entire program? Now, when you complete, the biggest thing for all of us is going to be recognition. So on submission of the project successfully, the students, all of you, will be getting the certification from NCC UK, National Computing Center. Now, we're all talking about programming, coding, robotics, and all that. Fundamentally, what is a program? What is going to happen in that? Or what are all these languages? What should we make from it? For example, if I want the robot to listen to me, I need to communicate the robot. Now, how do we communicate? Now, you understand English, I speak English. When both of us speak in the same language, the information is being transferred from me to you. But how do we talk to a robot? And that is programming, the language of robots. When you talk it, that is what is called as programming. And what are all these languages? There are so many languages in the world, depending on what is it you want to do. So you want to build an AI application, you want to program a robot, you want to build a website, you want to build mobile application, you want to do some cyber security. So based on what is it that you want to do, there are different applications and platforms for that. Today, we're going to learn and see what all we can do with animation and game design. Now, in animation, what is it that we can do? There are two types, first of all. So there is an option where you can do code like this, where it says the proper C, the syntax, the comma, full stop, the caps lock, the shift, the uppercase, lowercase, everything matters. Even if you make one simple mistake over here, it will not work. But on the right side, if you see, there is an option which is very simple. You can just drag it and drop it, and it starts working. Let us see one such example like this. All right, so I'm going to show you a program. Now, how many of you have played this game before? How many of you have made this game on your own? Now, this is a very simple game where you have to make the beetle walk, crawl, and solve this maze and go to the end without hitting any of the walls. Now, when you do that, what happens? You're supposed to win. But then what did I do? By mistake, I hit a wall. So what has happened? It has brought me back to the starting point. Now, let us try one more time. Without hitting, we need to move. But once we hit, we lose. Now, there are multiple parameters in this, if you notice. First and foremost, how much should the beetle move when I ask it to move forward? And if you see, once it touched the final goal, it has won, the celebration has started. But to do all this, the code is quite simple. Look at this. It starts from here and it goes until here. With simple logic, simple programming, and logical sequencing, we're able to build our own project from the scratch. And this, we can finish it off within 1 hour. That's the best part. Now, this is the starting part wherein you can build simple games. Now, how would you like to build some little more complicated games like Space, Challenge, and Battle? So this is a video game which all of us would have played in our childhood, where the aliens will attack us and we are defending the Earth. We, in turn, we make sure that we blast out all the aliens. Let's have a look at this. Now remind us, use a bomb. So if you notice, I missed, and what has happened? I have lost. Now let us try this again. Last time I have lost, and the game automatically stops. And here, if you notice, last time we had just one element, but this time we are having multiple elements. So what does each element do? What we're trying to do over here is we are interlinking multiple objects and what each object has to do with respect to the other object. Now, for example, the rocket has been programmed to move across the complete screen. Now, in this, what is it that we're going to do? We're going to apply simple mathematical principles. Like, for example, if I hit the left arrow once, how many pixels should I move? What is the total width? In each step, how much should I cover? And stuff of that sort. So this simple application of what we've learned in school in a practical way is going to happen. Step number one. Step number two, we're going to calculate the line of fire and we're going to see what all objects are going to come in our way. And once they come in our way, what should happen? For example, here we've said when the rocket moves and it shoots, if the bullet is touching the monster or no. If the bullet is touched, then we've said to change the sound. Otherwise, a different sound comes. So for everything, suppose if I get hit, what should be the sound? If the monster gets hit, what should be the sound? If the game gets over, what should be the sound? So for every step, you have the power to customize and build your own game just the way you can imagine. That is the basic step. Now, if you're going to go a little bit forward, this is about animation and game design. We've made some simple projects over here where we've built our own games according to our own concepts. And over here, what more are we applying? Concepts like scorekeeping. Now, what does scorekeeping do? In scorekeeping, what you are able to achieve is that you can now decide what is the point system and how much health do you want, how many points do you take to win, saving the high score. And every time you get hit, you have to reduce the health. And when health comes to zero, what should you do? So all logical things you can apply with coding and make sure that whatever you conceptualize, you imagine, you're thinking about, you can bring it to life. And the best part is this games can give to somebody else also, and they'll be able to play along with you. Next part. This is part A, where we saw about animation game design. When you finish here and you go to the next step, you're going to be learning how AI can help us in daily life. What is AI? AI is nothing but artificial intelligence. So what does this AI do? AI has multiple applications, sometimes even without us knowing it. For example, when you see many factories in many secure areas, they say that put your fingerprint and then we'll enter, let you enter. So what happens over there? When you put a fingerprint, it is matching the database of more than 1,000 fingerprints and telling who has entered, when they have entered, how many times have they entered, and when did they leave also in some cases. So like this in expert systems and speech recognition. So how many of you use your phone? How many of you use your Google Home, your Alexa, Siri by Microsoft? Siri by Microsoft? Okay, I'm just testing. Okay, now what else can we do? Not just speech, you can also go to face recognition. In face recognition, in many airports you have seen that there are cameras, and when somebody who's supposed to be arrested crosses by, immediately the relevant agencies are one and they get a nab him. That is possible because in a live stream, the image is being captured and being matched with a database of millions of people. And in text recognition, you have seen cases where when you scan your Google Lens, and it finds out from the image what is there in the photo. That text appears, and then you're able to read it or even process some information with it. Next, with regard to intelligent robotics. So you've seen that nowadays robots are talking with man. We ask the robot, why don't you bring me a glass of water? And why don't you make some coffee for me? So all that things is very much possible. Then in terms of computer vision. Now, computer vision is a subset. And what are all belong to the subset? We have speech, no. Do we have expert systems? In a way. Face, yes. Text, yes. And intelligent robots. Now, all these come under computer vision, and the possibilities are much more. Next, let us have a look at the simple applications what we can build with AI. The first and foremost we're going to be looking at is speech recognition. So how we are going to give commands, and the commands are going to be followed by our code. Let us look at the first one. Now, over here, if you see, this is a robot, or this is the backend where we are going to give some commands and it is going to follow. So what has the code done? First and foremost, we've asked our character to get introduced and then ask what is it that we would like our character to perform. Let's try that. And once we give a command, we're given three options over here, like music, speak, and run. So based on what command we are given, it will now understand, take things forward, and then modify. To modify to what extent? Whatever is the sequence of commands we have put over here is going to follow that and ensure that we get the desired output. Let us try this out. We've asked to start, and I click on the green flag. Let us start.
I am Nano. What can I do for you?
Run.
Run.
Okay. Now next. I've asked you to repeat what it has done last time, and therefore we'll first tell you and also ask you for the command simultaneously.
I am Nano. What can I do for you?
Music.
Music. I am Nano. What can I do for you?
Speak.
Music. I am Nano. What can I do for you?
Speak.
I love Dia.
So now if you see, we made a
Speak.
small change of voice and we've asked to speak. Now this is the first level. Now what more can we do? Now we can make applications where we can even understand the feelings of people. Now imagine when you enter the house and based on what you're speaking, the robot is able to identify if you're feeling happy or sad or what is your mood like. And based on what your mood is, you can also play different music, adjust the lighting and whatnot. Anything is possible with that. So let's simply see how that is being done. Here we're using an extension. What happens is when you first speak, the voice is converted into text with the help of the backend from Google. Now, once the text is coming, there's one more database where it's going to compare and check the nature of the word. For example, if I say good, is it a positive word or a negative word? If I say bad, is it a positive word or negative word? And there's also one more option that says neutral. In such a manner, we'll be able to classify different forms of feelings of what the person is feeling or the kind of language the person is using. And based on that, you'll be able to identify and take corrective action. So let us try that.
Hi, I am Nano. Say something about me, please.
Bad.
No, I am not.
So if you notice, Nano's face went from a smile to a frown. And Nano said, I am not bad. So what did Nano do? Step number one, Nano heard my voice. Step number two, converted my voice to text. Step number three, identified the nature of text. Step number four, decided what to do if it's a negative. If it is a negative, Nano has been asked to come back and say that it's not that way. Now let us try a positive word.
Hi, I am Nano. Say something about me, please.
Good.
Thank you.
Now look at the smile of Nano. It's become much, much bigger. So when I say a positive word, it has been programmed to respond in a positive way. Now let us try a neutral word.
Hi, I am Nano. Say something about me, please.
Okay,
It is okay.
so the response is also similar. As a next step, now, what if I had just programmed for three words and based on three words it responds? Why don't we test this code with multiple different words? Let us try that.
Hi, I am Nano. Say something about me, please.
Beautiful.
Thank you. Hi, I am Nano. Say something about me, please.
Ugly.
It is okay.
So does not understood ugly, right? I need to correct my pronunciation.
Hi, I am Nano. Say something about me, please.
Ugly.
It is okay. Hi, I am Nano. Say something about me, please.
Smart.
It is okay.
Right? So it creates a response filter, and according to what we say, it can respond. But what more? What about the different applications we saw like face, text, and intelligent robotics? Can AI save life? Let us go step by step. First one we're going to see is the example of face recognition. Now we have so many celebrities around us. What if across Google you say, I want this celebrity, the algorithm searches fully and comes back with the exact images of what you want. So how do we do that? With code, when you just put in an image, your algorithm can check and tell you who's the person in that image and give you the right response. And not just that, can even identify how many people are in the image and who is each of that person. Let us try it out. Now this is how the output looks like. First, analyzing it, there are two people. First is Robert Downey, second is Chris Evans. In this way, with AI, you can identify, recognize, and take actions. The next step, can AI save a life? Now imagine installing AI-based cameras in all the traffic signals. Now this bus is approaching, all right? When an AI system is there, you can identify if a child is still crossing the road. And if it is so, you can easily still keep the signal at red, and only when it becomes green, the bus would move. So like this, if you notice, person one, person two, and then bus. Like this, you can also make decisions to save lives. What more? With face recognition and expression identification, you can find out in a live video what is the emotional state of a person. So how does this work? Now, simultaneously, when the image feed is coming, the AI cuts this live stream into multiple images, and each of these images is compared with an existing trained model. Now, what is this trained model? Let us say that we are human. Now, when we are human, how do we know by just looking at a person's face that they are happy or sad? We know that only because we've been seeing people in that face. Now, we know that as humans, when somebody is smiling, they are happy. When somebody is looking low, they're sad. And when somebody is angry, they stare at us. So, by default, we as humans are able to understand the other person's emotional state based on facial expression. But how do we teach this to the machine? For that, we have something special, what we call as machine learning. Now, how does this machine learning work? Now, I need to teach and tell my machine that when somebody is sad, they look like this. When somebody is happy, they look like this. And for accuracy, what we do is we take multiple images. In our case, we take about 10 to 20 images, but for AI algorithms that are running in the real world, they take thousands of images. And why is that? Now, when you look at my friend post, if I'm smiling, you can take this and you can train. But what if I'm smiling like this? So you compare a side angle with the database. So when this happens, you need to keep on training the machine with what are the possibilities. More the training, more the accuracy. And when that accuracy is achieved, even with the smallest of differences, your code will not go wrong. Now here what is happening, we're able to check the expressions, identify the feelings of two children simultaneously. Let's have a look at it again. And if you also notice, they both are having different expressions simultaneously. So that is the power of the algorithm which you will be building. Now, if they are neutral, what to do? You can take action. If they're surprised, what to do? So the real-time scenario of this is when you enter a home and if you're happy, you can play a different music. When you're sad, play a different music. Control the lighting like that. Anything is possible. Or in even advanced cases, you might as well, in an automatic manner, we can make our AI assistant call a friend. If you're sad, as soon as you enter home, the AI has captured your photo and your friend will be called and you can talk to him. How good is that? This is also very much possible. So when we do all this, what are the skills that we are going to learn? First and foremost, in terms of programming skills, we learn how to think critically. So when we approach a problem, we try to understand how should we solve that problem, and we come up with creative ways which will help us to find solutions and implement the different modalities. Second thing is about cognition and concentration. The best thing about coding the best thing about coding is that you'll be able to focus, build your own code, and the entire process, the best part is, since you're building this from scratch on your own, the focus is there by default. So when people say that you get diverted, but when it comes to building games and building your own AI algorithms, your focus and concentration is much much higher. And beyond that, what is going to happen is you're going to be asked to make your own projects, and doesn't stop there. You'll be communicating, presenting, and showing your project to all your friends. And in the process, you'll be improving your presentation skills. And this project is not going to be just any project, it's a project that you're going to make on your own. So, what happens? You have the confidence that you can now build projects on your own, making you a confident inventor. And finally, the entire program is designed in such a way that one part will be supporting you by mentoring you, and one part we're going to ask you to do it on your own by looking at our specialized videos. So what will happen is you will learn how you can do things by yourself with minimal support from mentors, thereby making you a self-directed learner. Now what we're going to do is, since you all been such wonderful audience, I'm going to help you make your first simple project if you have not already done it. Now, what is the project we are going to do? So, if you already know Scratch, I'm sure it's not a big thing for you. But if you have not done some coding before, I will be helping you to make your first project. Now, what do all of us love the most? Correct. It is our name. So today, what we are going to do is we're going to give some special effects with animation to our school's name. And you can repeat this with your own name. Okay. So what is our school name? Correct. So let us start and let us see how we're going to go ahead with it. First and foremost, let us have a backdrop. Now, in the backdrop, you can choose what is it that you want to have as a stage. Now, this is my stage over here. I've created a blackboard as a backdrop. And on top of this, I need to add the first alphabets of my school name. So for that, I go to choose a character, and here I'm going to choose letters. Okay, so what is it? K. Okay, next, you have multiple options in this also. You have this type of letters as well as this type of letters. Second, P. And third, we're going to go for the alphabets again. Letters, it is yes. Now, what are the effects that you can do? In very simple manner, if you feel that the alphabets are of different sizes, you can just go to size. I'm just going to increase the last one. You can make it 150. Now it looks big as well. Now, once you're done with this, You can take your name, the first alphabet, your parents' name, whatever you want. And once you're done with this, what you can do is you can go back to coding. If you see over here, let us say K is going to be a first character. What you can do with K is you have multiple options like making it move, turn, or also making it speak. All right. And also in terms of sound, you can create or play a sound when it is active. And also in looks, there's something called as an effect. You can also change the color percentage. You can also change the size. So everything is possible. So with K, it will start with a simple animation of motion. For example, turning clockwise, turning anti-clockwise with a small delay in between. Now this is how you add a delay. And to make things work continuously, what you do is you need to tell them when to start and also how long to run. So once we do this, the first part is done. Now K is going to turn around left and right 15 degrees every 1 second. Let us check this out. Like a tick tock, tick tock. You see that? Now K is move. Now, what do you want to do with P? With P, let's just say, can change the effects like color. So for that, let's go to FX. Where is FX? We just saw FX. Right, it is in the bottom. So the first effect you can change is maybe say fisheye, and then you can also change the color. All this by 25%. And if you require, you can also change the size by 5 points or 5% as you would like it. And again here, make sure that you tell the code how long it has to run, when it has to start, and how frequently it has to work. So every 1 second, this effect is going to happen. And for yes, let us play some music. So when do we start? Correct. When the flag is clicked, you go to sound, and here you're going to play the pop sound. Let's also give some effect. So here, let's make yes move 10 steps, come back 10 steps. So 10 means 10 steps on the right, and minus 10 means 10 steps to the left. And in between, we make sure that we add a delay so that we're able to see what is happening. And we missed one thing in this code. Any idea what that is? Right. So only if you add forever, it keeps running forever. Otherwise, it just runs once and it stops. So let's try our code to see how this animation works. What you're going to do is you're going to go back and try to animate your name by yourself. And here we go. That's it. Animating a name can be as simple as this. So what more? What is it that we can do beyond this? We have also achieved a world record where we worked with more than 15,000 children, which you've also been part of and made us achieve. Thank you for your tremendous support. With your support, we made it happen. So like this, we can do much, much more when we learn how to code and how to make things come to life. And this is one of our students who has made a code. He has been appreciated by Dr.
Thank you. Yes, ma'am. Thank you.
And also some of our students who've been on the cover pages of magazines. And we received the award for excellence in robotics education. And again, our students winning the best technology solution award, and us winning the best award for robotics education. And I am sure when all of us work together, we'll be able to build wonderful projects and bring all our ideas to life. Thank you so much. And back to Clement.
Thank you so much, everybody, all children, principals, and the management authorities who have joined here. If you have any queries, you can put it on the chat box.
So children, we have something special also for you. Now we've seen coding. Would you like to see some robotics as well? So coding is the first step to robotics, right? So in this summer camp, we'll be focusing more on coding the summer in this year. But after learning this, you can even go much ahead. So I'm going to switch my camera and I hope you can see our friend over here. So this is called Auto. Now this guy is a 3D printed biped robot who can walk, who can respond to your commands, and even find obstacles in front and take things from there. All right, so let's try to work with Auto. Now what can Auto do? First and foremost, if you see, even for companies like Honda, they took almost 40 years to make robots to climb a staircase. And when you work with Auto, you learn how to bring the different principles of physics, mathematics, computer science to life and make robots perform as you would like them. Or what? See what how Auto is walking. Now as soon as Auto sees obstacle, Auto starts walking backwards. And once it is clear, again forward. Once obstacle is there, again starts walking backwards. Now, what is so special about Auto? You see, Auto is completely 3D printed and is able to balance his weight even while standing up. Now, this is one part of it. Now, what more or where else can robotics be used for us? If you see like this is called as an industrial robotica, but this is a smaller version of it. Now, what can this do? So this is a robot that is being used in factories that manufacture our cars and where instead of humans building it step by step, robots assembling it faster, making a delivery smooth and making sure it will finish on time. Let us see how a pick and place robot works. Now in this way, you can make robots work according to whatever your wishes. And this, if you see, it's a simple tool which we can own, we can build, and we can manufacture. This is completely 3D printing. In advanced cases of 3D printing, you can also make objects like this. For example, this cat, you see, is worked on an interlock basis where it is completely flexible and built with two materials simultaneously. So like this, the first step, the foundation for everything is about learning how to code, and step by step from there, we go forward. Wishing you all the best for a wonderful future. Thank you.
Thank you, Uday.